Mountain View's Aron Wall lives and breathes science, pondering fundamental insights about quantum field theory and gravity that have earned him this year's prestigious Breakthrough New Horizons in Physics Prize, to be awarded in a red carpet ceremony at NASA Ames on Sunday. That the 34-year-old believes just as fervently in divine intervention, which saved him from traditional education, where he had been forced to repeat algebra and was uninspired by geometry, while his heart sang with Einstein's theory of general relativity. I was in trouble. It felt like a very gloomy tunnel, with no way out. I needed someone to step in and rescue me, said Wall, a devout Christian who worships at New Life Church in Cupertino, part of the Church of the Nazarene. It was Providence. God acted through Middle College, a foothill college program in Los Altos Hills where he flourished, emotionally and intellectually. Gravitational research scientist at Stanford University, Aron Wall poses for a photograph with his explanation of how to make a traversable wormhole from two quantum-entangled black holes. Guy Sagano, Bay Area News Group, the son of Gloria and Larry Wall, who created the Perl programming language. Wall went on to write an award-winning PhD dissertation about black holes and the second law of thermodynamics, and study at the Institute for Advanced Study in Princeton, NJ. He is now conducting research at the Stanford Institute for Theoretical Physics and will head to England's University of Cambridge in the spring. He explains physics and theology in his personal blog, Undivided Looking. Okay, what do theoretical physicists actually do? It means I think for a living, talk to people about it and then write it down. The cartoons show the physicists wearing lab coats, but as a theorist, I don't do experiments. We think about some area of physics and do calculations or computer simulations. I often take a theory we already believe, then prove something that is true about it. As a child, what attracted you to physics? I liked the orderliness of it. There was a sense of a pattern that people are working to understand, and it is not fully understood yet. All these particles have different masses and nobody really knows why. My family would go to the Mountain View Public Library about once a month, and I would check out books from the children's section upstairs. One day, I checked out a book about physics to take home. The chapters of the book were about things like force, pressure, and energy, which seemed boring to me then. But near the very end, it said that scientists had recently discovered that subatomic particles, such as protons and neutrons, are made out of even smaller particles called quarks. That surprised me because I'd never heard it before. From then on, I would always check out some physics books, like Stephen Hawking's A Brief History of Time. I would make charts of all the known elementary particles and try to figure out what other ones there might be to fill out the pattern. School proved challenging. What happened? I learned algebra in the 4th grade from a cute book called Algebra the Easy Way, and by the time Crittenden Middle School put me in an Algebra I class in the 7th grade, I was already on the verge of teaching myself calculus. The algebra teacher made me repeat the class again in the 8th grade, even though she knew I knew everything, because I never turned in any homework. Aron Wall, then 13, posing at the building in Stockholm where the Nobel Prize in Physics is awarded, during a family trip to Europe. Courtesy of Aron Wall, by the 9th grade, I was stuck in honors geometry, but thinking about Einstein's theory of general relativity instead. If I had stayed at Los Altos High School, they actually would have dropped me down from honors geometry to the non-honors trig math analysis course due to getting a C, partly due to not turning in homework, and partly due to not remembering all their silly rules for how to write proofs. How did you get out? A high school counselor recommended to me the Middle College program, which takes students who have difficulties with the normal high school program and has them take community college classes at Foothill College instead. They only take juniors and seniors, so I had to skip my sophomore year to get in. When I was doing the orientation for Foothill, they gave a math test and I got the highest score. So they placed me into calculus immediately. My most inspirational Foothill College teachers were Christopher DiLeonardo in geology and Robert Hartwell in music appreciation. Psalm chapter 107 was particularly meaningful to me during this time. It is all about people suffering from various kinds of hardships. The Lord saves them from their distress. College must have been even better. I went to St. John's College in Santa Fe, which is a weird great books college that teaches all subjects using primary sources and discussion classes. I knew I wanted to be a physicist, but I was attracted to the idea of a school where I would learn about everything else too. Any favorite books? Plato's Dialogues with Socrates. A lot of people don't realize how accessible Plato is. It's really just a bunch of guys having a conversation. I also enjoyed discussing the Bible with other students who weren't necessarily religious, since they were seeing it with fresh eyes. Why did you choose the University of Maryland for your PhD, rather than some big-name school? I chose it because I wanted to work on quantum gravity, but was skeptical about the truth of string theory because it has no direct experimental evidence. Most of the famous universities are very string theory-oriented. Physicist Jacob Bekenstein and Hawking had conjectured that black holes obey the second law of thermodynamics, which is about irreversible one-way processes in nature. My PhD dissertation research proved that their conjecture is correct, and was later awarded the Bergman-Wheeler Thesis Prize. Faith is a big part of your life. How can a physicist believe in something that is so deeply mysterious, and not testable through direct evidence? Everybody has a way of looking at the world. A computer programmer looks at everyday life situations and thinks, algorithms. As a physicist, I'm trained to look at ideas and say, approximations. All of our theories about what is true, they are valid in certain patches, but we don't know the whole. There are so many examples where a theory works well and then breaks down in one way or another. In science, we have to have something that works well to understand the world we're in, but for something outside the physical universe, like God, the theories fall flat on their face. I think the evidence for Christ comes in the form of historical data, like the miracles Jesus did and his resurrection. And also our personal spiritual experiences. These are different types of evidence than what we measure in science. Often paradoxes are our best approach to understanding the universe. Consider your two eyes, they let you see 3 dimensions. You don't say, my 2 eyes contradict each other. See, I can't believe either. I believe in a deeper reality than the laws of physics that we know now.